So today we start our study of fractions. You'll feel, hopefully, like most of this is review, but we spend about a week reviewing concepts you learned in algebra and extending them into algebra 2 difficulty level, essentially. So we start our fractions study with remembering what makes a fraction undefined and how to reduce fractions. And so I'm going to go through a few examples with you today and be done. If you get it, you can certainly fast forward. Again, what I always suggest is that you jot the examples down. Try them on your own if you think you understand, and then fast forward to the answers. If you don't get it right, then rewind and see what I did that was different. Okay, so the first thing we're going to talk about today is what makes a fraction undefined. Well, fractions are undefined when the denominator, which is the bottom, equals 0. You can never divide by 0. So if I look at these examples, I don't care at all about the top because I'm wondering what makes each of these fractions undefined. So I look at the denominator of this first example and all I have is an x. So the value of x that makes that fraction undefined is 0. So what we say is that x cannot equal 0 because when I have a 0 here for x, my fraction's undefined. When I look at number 2, I have an expression x minus 3 that can't equal 0. Well, what number minus 3 gives me a 0? 3. So I here say x cannot equal 3. What you're essentially doing is setting each denominator equal to 0, or actually not equal to 0, and solving. So for this third one, I see x squared minus 2x minus 15. Seems tougher, but we have under our belts factoring. And factoring and fractions are best friends. They go hand in hand. So you have to be a really good factorer to be successful with fractions. Make sure you keep practicing factoring. So this is a trinomial. I'm going to think about product sum. I need two numbers that multiply to negative 15 and add to negative 2. And they are negative 5 and positive 3. Now, I was able to do that really fast because a was 1. Remember, if a is not 1, you need to split the middle. So I think of each separate factor and that each one cannot be equal to 0, because if either of them is, 0 times anything is 0. So here, x minus 5 can't equal 0, so x cannot equal 5. And here, x plus 3 cannot equal 0, so x cannot equal negative 3. And you're done. The last part of today is simplifying fractions, or getting them in reduced or simplest form. Now, the key is, again, factoring. You always factor first. You can never cancel things top to bottom that are attached by pluses and minuses, unless they're entire factors. For example, in number 1, I can't cross these 12s out, because this 12x squared is attached to 4x by a plus sign. So instead what I need to do is factor. Well, 12x cubed doesn't really factor, so that's going to stay put. 12x squared plus 4x has a common factor of 4x. So I'm going to take that out, and I'm left with 3x plus 1. Now that I have a number being multiplied by another number, I can cancel like factors. So 4 divides into 12 3 times, x divides into x cubed once, and I'm left with x squared. So my numerator is 3x squared, my denominator is 3x plus 1. Again, these 3's can't go because they're attached to this 1 by a plus sign. So you've reduced as much as you can. Okay, again, I'm going to do a couple more examples. If you need them, fine. If not, fine. I would certainly try them on your own if you don't want to listen to me and then just fast forward through the answers. For number 2, you want to factor both the top and the bottom because we're reducing or writing them in simplest form. That I've factored, I can cancel like factors top to bottom. X plus 1 and x plus 1 are the same and they're multiplying by something else. So now it's a legal move. And I'm left with x minus 3 over x minus 2. Okay, so number sum, two numbers. Now, this denominator is the difference between two things factored. I can cancel like factors top to bottom. So one of these x minus 3's goes, And I'm left with x times x minus 3 over x plus 3. Okay, number 4. Notice what this looks like. Look at x minus 5 and 5 minus x. All my letters and numbers are the same, but all my signs are the opposite. Anytime that happens with binomials, a two-termed expression, where I have a positive x on top and a negative x on the a negative number on top and positive number on the bottom, if everything has the opposite signs, they reduce to -1. So I always leave my -1 up top. It's just a good habit. -1 divided by +1 is -1. I'll show you why that's so special in class tomorrow, but for now you just need to know that special reduction. I can't factor or reduce anything else, so I'm just going to gather things up. I have -1 times x plus 2 over x minus 1. Okay, so the big rule there for reducing to -1, you want to get this in notes for sure, is anytime I have two binomials of the form a minus b over b minus a, signs are opposite top to bottom for both terms, that equals -1 every single time. That's a really big rule that you want to learn as soon as possible. Okay, last one. Got that -1 reduction again. I have +4, -x, +x, -4. They reduce to -1 over 1, and I'm left with 2 times -1 or -2 over x minus 4. Okay, that's it. Have a good night.